gravitation. We have already studied that Newton discovered that every object attracts every other object in this universe, and the phenomenon is known as gravitation. On the basis of the factors on which this force depends, Newton formulated universal law of gravitation. In this module, we will study about the Newton's law of gravitation. Newton's universal law of gravitation. Every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. The direction of the force is along the line joining the centers of the two objects. Mathematical expression of Newton's universal law of gravitation. Let A and B are two objects of masses m1 and m2 respectively, and r is the distance between their centers. If F is the gravitational force of attraction between these objects, then according to Newton's law of gravitation, the force between the two objects is directly proportional to the product of their masses. And the force is inversely proportional to the square of the distance between their centers. Combining both the equations, F is proportional to m1 into m2 divided by r square. Replacing the sign of proportionality, F is equal to G into m1 into m2 divided by r square, where G is a constant of proportionality and is called as universal gravitational constant. From the above, we have G is equal to F into r square divided by m1 into m2. So, SI unit of G is G is equal to capital N into small m square divided by kg square. If m1 is equal to m2 is equal to 1 kg and r is equal to 1 meters, then G is equal to F into 1 square divided by 1 into 1 is equal to F.
उसका यूनिवर्सल लॉ को जो प्रूफ करने के लिए यूनिट वगैरह में जो आप लोग को प्रॉब्लम है तो वो सब चीजें क्लियर हो रहा है? चेयर पकड़ गिरा दे।
The value of G was found out by Henry Cavendish 1731 to 1810. Numerically, G is equal to 6.67 into 10 raised to the power minus 11 Newton meter square per kilogram square. The value of G is always constant. It neither depends on the masses of the objects, nor on the distance between their centers, nor on their shapes, size, nature, or medium separating the bodies. As the value of G is very small, therefore, gravitational force between any two ordinary objects will be extremely weak. From above, we can say that universal gravitational constant G is numerically equal to the gravitational force of attraction between two bodies.